Hi, in this video we will study the invertibility of orthogonal matrices and properties of the inverse of such matrix. Well, let's recall that a square matrix Q n by n is orthogonal. Well, the definition says that if its column or its columns form an orthonormal basis. And we saw that this has an equivalent version, which is Q transpose Q is identity. So that's other equivalent condition. But you see, if you have Q transpose times Q equals to identity, means that we have found a matrix. When we multiply to Q from the left, it is identity. Well, remember that we had a property, we had a theorem that if you find such a matrix and you switch the order, so you do first Q then Q transpose, you still get identity matrix. And well, this right away tells me that fact, all orthogonal matrices are invertible. And well, what we showed here is that even more, and the inverse of orthogonal matrix is just its transpose. Well, actually, this is if and only if. A matrix is orthogonal if and only if it is invertible and its inverse is the transpose of that matrix. Okay. But an interesting fact is you can go a little bit further that, well, when you have Q and Q is orthogonal, then you see that a Q transpose Q identity, we just did this, implies that Q transpose is identity. And from this, well, you can write the first Q as Q transpose transpose. Transpose of transpose is the matrix itself. Now, what we found here is that Q transpose times the transpose of Q transpose is identity. This implies that Q transpose is also orthogonal. And we know that Q transpose is Q inverse is also orthogonal. Okay. And from that, this is an interesting fact. So now let me write this one as fact 2, that if Q is orthogonal, then Q transpose and its inverse also are orthogonal. And we know that orthogonal, so Q transpose is orthogonal, means that columns of Q transpose form an orthonormal basis. But we know that the columns of Q transpose are the same as rows of Q. So rows of Q form an orthonormal basis. This isn't it interesting? We started with score matrix whose columns are form orthonormal basis. Now we can conclude that also the rows are orthonormal basis. So this is the fact 3, that for us orthogonal matrix, we not only have columns forming orthonormal basis, also rows form orthonormal basis. Orthogonal matrices are invertible. Their inverse is the transpose of those matrices.